Good morning, good afternoon, good evening, wherever you are. Thank you for joining us for the second in our series of webcasts from CIQ. We appreciate you spending your time with us. Today we have discussions more around what we started last time, talking about migrations. We have some other things to update you on. So Forrest, I appreciate you joining me today. Neil will be here shortly. So last time we went through and talked about a migration script and kind of what that looked like. This time we kind of want to focus on what a migration looks like small business, medium business, how migrations take place, why you would do a migration. And a lot of times we find that people aren't just migrating from one operating system to another, but they may be migrating from one environment to another. So on-prem to the cloud, on-prem to on-prem, maybe you've got a new site you're trying to build. So we'll kind of dive into some of those topics here in a little bit. And we also wanted to just let you know, we are CIQ. We are focused on the HPC community for an entire stack for HPC 2.0. We have several projects. We have Warewulf, we have Rocky, we have Singularity, and some others. But we have a lot of enterprise customers who are interested in Rocky as well. So we are appreciative of your guys joining. I'll let Forrest introduce himself.
All right. Well, hello, everyone. My name is Forrest Burt. I'm a high-performance computing systems engineer here at Control-IQ. So I work a lot with kind of the user side of some of our high-performance computing stacks and kind of generally with some of our high-performance computing operations. So I'm excited to be here and discuss kind of migrations and such as they relate to HPC.
So why don't we dive in there, Forrest? Let's talk about migrating HPC. I know you've been doing a lot of work on that lately and kind of how that migration goes. A lot of the people that you've been talking to are CentOS users today. They've got the desire to move off of something and to be into something that's going to continue on with CentOS going away. And they're looking at Rocky, and a lot of them have actually been moving to Rocky. And I think from the node perspective, it's a lot easier. I think there's a lot of challenges and a lot of things that need to be taken into account and looked at from the head node. So how's that going? What does that look like? I mean, can you kind of help us from a best practices standpoint?
Yeah, so essentially in any high-performance computing cluster, you're going to have more or less two different types of node. There are other things that you can look at. Some places, have dedicated nodes for data movement, dedicated nodes for, things like Grafana, that kind of stuff. But primarily, the two things that you're going to be looking at that you're going to have in most HPC clusters are going to be head node or a head node or multiple head nodes and the compute nodes that are going to actually run your computations. Zane, as you alluded to there, the compute nodes are typically pretty simple to be able to update from this. Compute nodes are typically just, kind of nodes that receive their configuration through something like iPXE booting. So typically your head node will have some type of provisioner or something like that on it that I will kind of discuss a little bit more in depth in a bit. Typically your head node will have some type of provisioner or something like that on it. That essentially allows you to all at once affect what's going on with the configurations of those compute nodes. Essentially meaning that because those compute nodes don't have anything typically stored on them, they're basically just for providing resources for computational jobs. When you're migrating those from CentOS to Rocky Linux, those are typically a pretty simple operation. A lot of places probably already have a system image or something like that that is spooled up, that is kind of their generic compute node image that is served out to compute nodes when those need to be reset or something like that. So migrating your compute nodes on a cluster is basically as simple as kind of changing those images that you're using for those different compute nodes there. And I know that a lot of places have different types of compute nodes. Potentially you have ones that are just CPUs, potentially ones that have GPUs on them, ones that maybe have a lot of RAM for high memory jobs. And so there's, obviously different considerations there. You'll have to make sure that, your GPU drivers and stuff like that are all set up correctly for Rocky. But in general, the compute nodes themselves are pretty easy to kind of reconfigure and to be able to serve out kind of a new operating system and new stuff too. Zane, as you kind of alluded to there, it's where you start to get into head nodes that things get a little bit more specific. And for anyone not aware, the head node of a cluster is essentially the controller node for it. A lot of clusters will essentially have one head node where you're running things like your job scheduler, your database services, all that kind of thing. Sometimes you'll see configurations where there's two head nodes, one of them acting as a failover for the other, so that if the first head node goes down, it can fail over and immediately pick back up on that other head node. Sometimes you'll see two head nodes to kind of run, one's running, for example, I'll take the scheduler Slurm as an example. Sometimes you have one head node that's running the Slurm service on it, and another head node that's got your Slurm database servers and stuff like that on it. So head nodes can be kind of an interesting configuration. They're definitely very specific to each site, depending upon kind of how you've configured things. So there's a lot of different kind of considerations there if you're migrating your head node from CentOS to Rocky. First off, you'll want to look at obviously backups and things like that. Making sure that your Slurm databases are all backed up. Your just general databases for things maybe like your monitoring stacks and stuff like that are all backed up. It's a pretty specific configuration, so it's something that's best planned out kind of in advance, because it's kind of a drastic change to move a head node from one operating system to the other. So in general, my comments on that is, like I said, plan that well in advance. Make sure that all the data you would absolutely need in order to rebuild that server is ready and kind of stored away. So make sure that you fully understood, where things are stored, where, Slurm is moving things, where, like I said, your monitoring stacks could be putting things, where your databases are putting things. There's a lot of sensitive information that, needs to be preserved through that, and wouldn't want anything to happen on migration. So as far, like I said, as head nodes go, they can be kind of a lot more of a complex case that can almost be kind of down to the server itself. Like I said, every cluster is a little different. There's some commonalities in the software and stuff like that, but as far as head nodes go, that's something that's really best planned well in advance, and it's best to make sure that everything that needs to be understood that head node is doing is understood and made sure that will continue when it's moved on over. There won't be, any kind of interruptions in service there because of the migration.
So, Forrest, have you seen challenges in those air-gapped environments where you're trying to install Rocky? How are you going about dealing with those, where you're going to have to pull down an ISO, or you need to get the packages that are outside? Does that become a problem, or is that something that you worked around pretty easy?
Do you mean an air-gapped environment in general, or kind of an air-gapped high-performance computing environment?
Either one. High performance seems to be the place that we see that the most often. It seems to enterprises have a little more flexibility when they can connect things to the internet versus the HPC environment. That they seem to be a lot more secure. So, has that become a problem? Is it something you're running into?
I myself haven't seen that too much. I know that, for example, in clusters, it's a pretty common configuration for your compute nodes to not have internet access at all. So obviously, from the compute node standpoint, serving out new images and stuff like that to them will pretty much, involve an offline operation anyway. But with your, head node potentially that's an air-gapped environment, that becomes a little bit more complex. While I haven't quite migrated something in that environment, I would imagine that there are pretty easy ways to get those files that you need from, Rocky's different, places, the ISOs, stuff like that out there. Throw those onto, just kind of the standard boot drive or something like that, and be able to move that stuff onto there. So my best practice there is probably just standardly what you would do. Moving that stuff over, making sure you have those offline copies of repos and stuff.
Perfect. Thank you. I think Neil has been able to join as well. So welcome, Neil.
Hey, thanks for having me.
Absolutely. So
just to add on kind of to what Forrest was saying too, Rocky's Mirror Manager instance that we're using supports private mirrors. So if any organization wants to have a private mirror that only they're using and redirect all of their hosts to use that automatically, that's something they can go and sign up on the Mirror Manager to subscribe a private mirror to.
Thank you, Neil.
Yeah.
So Neil, I think there was one thing that you brought up to me yesterday that you wanted to update everybody on around the script, the Rocky migration script.
Yeah, so yesterday, or a few days ago now, I guess, on January 31st, CentOS had, in accordance with their end-of-life policy, removed all of the CentOS 8 content from their mirrors, and I've been seeing it cause some people some problems in their CI environments and elsewhere where they're expecting those images and files and our repos to be available, and it actually affected the Rocky migration script as well because we were making an assumption there. But we did have a little bit of foresight there and pulled down a copy of the CentOS vault to some of our servers and have switched over that script to update your system to the latest CentOS version using the copy of CentOS 8.5.2111 that we pulled down, and just orchestrate the whole update and migration process from there. And it's working pretty well so far. So that was a great addition that one of our community members added to the script.
Yeah, so if you downloaded that script before, yesterday, make sure you go get a new copy of it, because there are changes in it. You can go back and look and see what the differences are and add it yourself, or just go download the new one and make it work for you. So
for sure.
Absolutely appreciate it, Neil. So Neil, we were talking about migrations, and I've done a lot of cloud migrations, done a lot of data center migrations over the last 20 years. It seems to be something that most of the enterprises in the last 10 years have kind of figured out how to go about doing that. So they've got their operating systems, they've got their standards. When it comes time to move, they're a little bit further along or more mature. But if you look at small and medium businesses, a lot of times they just don't have the resources, they don't have the time. I mean, obviously you run into constraints, and you have an operating system that you've built out. Small business I was talking to, for example, they've got a closet full of gear. They don't really have a full-time IT person. They're actually downsizing their environment, and that rack has to go somewhere. So it is old. They're looking at moving those CentOS servers to something, and they're trying to figure out what that looks like. And if they look at moving to the cloud, they want to move to Rocky, but they see that as, that's not something we've built before. That's actually built by someone else. Kind of a, what do we do? How do we go about doing this? And I think there's a lot of things that are missed over time as small and medium businesses grow. They don't have the time to do it. So the configuration management is missing. Automated deployments of applications are missing. Maybe they've gotten just tech debt. Things have gotten really old, and it becomes a problem. So as a Rocky community, what can we do to help with that? Or what does that look like if you're going to do something like that?
Yeah, it's a great question. I think that the proliferation of the cloud over the past 10 years has just been something that has really affected anyone. And to your point, with a small amount of servers, like you do need sort of a critical mass for it to make sense for your business to move over to a configuration management standpoint where you're not just configuring things by hand. And it requires specific knowledge on different tools that are being used, whether it's Ansible or Puppet or Chef or any of those sorts of things. You have to have the knowledge there to make it work. And often there's a pretty big learning curve on making these tools work for you instead of kind of against you. I faced that myself while learning a lot of them, and it can be the best practices kind of around how to use them, how to ensure that if your server goes down and you need to rebuild it, you can just do that. It's tough, and it takes a lot of time too, and especially for small and medium businesses, there's likely not a lot of time that person has. That's not a full-time IT person to be redeploying VMs and make sure that they are working and check their whole disaster recovery plan, if that's even something that they have. And so I think the cloud is something that's very useful, but you have to be kind of careful with it too, because especially transitioning out of that CapEx OpEx model, which you can talk to your finance team and see if they believe you that the cloud is OpEx. But the whole idea kind of using the cloud is that it will save you money, and unfortunately in a lot of the clouds there are just ways that you can spend way more money than you have to, because it's easier to click those boxes. So I in some ways there are different problems that are the same that you have to solve in the cloud for making sure that you're architecting your cloud environment properly and not overspending on cloud, not spending $50K when you could be spending $5K a month, for example. And those are not easy things for small and medium businesses to do, for the same reason that configuration management isn't easy for small and medium businesses to do. They require domain knowledge of that specific tool, whether you're talking about AWS or Google Cloud Platform, Azure. You have to know the ins and outs of them. It can be scary to try and look at that, especially when you don't know how much you're going to be spending and everything else. But the good news is that Rocky is available on pretty much every major cloud provider as a free image that you can just go down and pull and deploy that out into, on AWS, it would be a VPC, and maybe you have a web application or something running that you need your users to connect to. And a lot of the clouds really are adopting this zero trust network access format to access all your services remotely in a secure fashion. And that also comes down to the architecture of the programs and applications that you're running in themselves. And to their credit, AWS, GCP, Azure, they have a lot of great documentation on how to architect those things in a cloud environment. Though, again, you have to take that with a little bit of grain of salt, because they may be the best recommendations, but they might not be the cheapest recommendations. In some cases, you may need to go and look at different options that maybe you have to architect the high availability or disaster recovery yourself, but save a lot of money in the end. And that's where these sorts of tools really come into play, I think.
Sure. So I think one of the other things that becomes a challenge and a problem is a lot of times whenever you've licensed an operating system to run on-prem, it doesn't necessarily transfer into the cloud. So you can have some licensing issues, or just because you have a license with someone or a subscription with someone doesn't mean you can run it in the cloud and still get support. And I think that's something that we've done a little bit differently, being able to support the community. It doesn't matter where you run it or where you installed it from, but that really gives us a little bit of a different view. Love to hear your feedback on that, Neil Forrest, kind of.
Yeah, licensing is, I think, a constant problem for everyone. I've seen it myself in CI environments, not being able to use RHEL, for example, because it's hard to subscribe the systems in a convenient manner when you're running jobs multiple times a day. And so Red Hat has added some stuff like some content access to help with that. But really, what I like about Rocky is being able to use it as a parallel or an analog to RHEL and run those jobs in my CI environments that I need to, and not have to worry about the licensing in that way.
So whenever you deploy from the marketplace and any of the big providers, Amazon, Azure, Google, that image that you deploy from the marketplace, we would support it. Doesn't matter.
Right. Yeah. Yeah, there's it's not like you have to go and subscribe a system or whatever else. Yeah.
Perfect. So from my consulting days, I know it was always a challenge of finding the time to actually do those configuration management pieces and to go through and make the effort of automating deployments so that you could move if you had to. It always came down to, I have to do something now, and now is the time to invest the time. But getting someone to actually spend the time to do that automation was always hard. And I think it became a conversation of, but if you don't do it now, you're going to run into the same thing in 2 or 3 years, and you're going to have to invest a ton of time and money. So I think if you're going to make this move, now is the time to start doing that configuration management. And I think it's important to realize that all of the tools that are out there, not all of the tools, but there are a lot of the tools, the big tools that are out there today are supported on Rocky. Correct. I mean, if it's Puppet, Chef, Salt, Ansible, all of those work on Rocky today.
Yeah, and not only do they work on Rocky today, but it should be an experience that you can simply redeploy the server using Rocky and use that same configuration management, because it is a one-to-one compatible Red Hat Enterprise Linux build, which is what CentOS was as well. So, there may be a couple of tweaks that you need to do, and there's definitely some pitfalls, which we should definitely put an article together on to make sure like your Ansible version's updated and that kind of stuff. But the Rocky community has done a great job of upstreaming those changes into the different configuration management tools that the Rocky users are using. So they have a vested interest as well in making sure that Chef, Puppet, Ansible are working properly on the OS as well. So a lot of that stuff is fixed at the tooling level, and thankfully a lot of it's already been fixed at this point.
Excellent. So I think one of the other questions that we've seen quite a bit today, or up to today, has been what is going to be different and what's going to keep Rocky from going away, like what happened with CentOS. I've run into that, Neil, you and I were on a call the day before yesterday, where that was a very interesting topic that was a lot of passion behind it. And yeah, I think it's important that we describe that. So if you don't mind.
Yeah, no, absolutely. I'd love to. I think that is something that everyone is still very sensitive to of a subject because of the change last year. And looking back at it a year later, I feel personally that it wasn't the best thing to do, and I think that there's a lot of other people out there, including folks from Red Hat themselves, that admit that the change midstream of CentOS 8 to CentOS Stream, which was a terrible sentence, was not the best move, and that they wish they had been done different. And I think that's kind of where I see it now too, right? Like I wish that it had been done different for the change for CentOS to CentOS Stream. But in terms of what happened to CentOS being EOL'd and changed to Stream, I'm a bit on the other side of that. I'm really excited about the changes that Stream has brought, and will enable us to help the enterprise Linux community and submit things and contribute upstream to those jobs that are working. And in terms of it going away or being bought, I enjoy the structure that we as a community have come up with for Rocky Linux, in that it is very much led by the team, and there's a nice team of people that are providing guidance and expertise on how to set up the governance of that project and make sure that something like something like what happened with CentOS doesn't happen again for Rocky. And that's something I think that all of us on the team are very committed for.
So Neil, I think it's also another, you bring up an interesting point when you talk about SenseStream and kind of what that is. I don't know that everybody has a great sense of what that actually is and how that gets contributed back to. I think there's a lot of misunderstanding of, is it something you contribute to? Is it something you can't? Does that have to go to Fedora first? Like, what does that flow look like, and how do you actually contribute back to Stream?
So historically, the flow has been kind of, you spray something at Fedora and hope that it makes it into a RHEL release. And that was never really something that was helpful for enterprises or people that wanted bugs fixed or wanted to get their code contributed up into things. It was often a multi-year process to be able to have those changes integrated. What Stream has done is kind of flipped that around on its head, and there's a little bit of nuance here with CentOS Stream 8 and CentOS Stream 9, because the contribution model, just because of the change midstream, is a little bit different. So the way I can describe it, and there's a great tweet by Carl George from Red Hat about explaining this the process here. But CentOS Stream 8 is technically a rebuild of RHEL. Technically. CentOS Stream 9 flips that around, and it becomes that Red Hat Enterprise Linux is technically a rebuild of CentOS Stream 9. So the contribution models are a little bit awkward for 8, but for 9, there's a very clear path for making contributions to the CentOS GitHub for CentOS Stream, or GitLab, sorry, and creating tickets or merge requests to have those merged back in. And in CentOS 8 Stream, it's a little bit different. You have to kind of open some Bugzilla requests, but generally the contribution process is the same, and it allows us as engineers that are working on problems in Rocky Linux that we see customers using to upstream those changes into CentOS so that they'll become packages that are just defaultedly available, or fixes that are defaultly available in the upcoming release of whatever that operating system is. So in terms of the contribution, it's a little bit finicky and you got to wrap your head around it a little bit, but it's something that I am genuinely excited about, to be able to shape the future of enterprise Linux.
Excellent. So how do you see that playing out with, what do you see happening to Fedora? Where does that live? If you don't have to go all the way to the top anymore, do you see Sense going back up and going down? I mean, how is that going to look?
So ultimately, yeah, that's a great point. Like, you have to upstream those changes again from CentOS Stream into Fedora, because CentOS Stream itself is a cut of Fedora. And that's a great point. It's the release cycle, I believe, I'm not even going to say it because I'm going to say it wrong, but the release cycle of Fedora, CentOS Stream, RHEL, and then the derivatives thereof is very clearly defined now, where it's not that it wasn't before, but it was maybe not as public as most people would be able to see. And so there's that path, knowing where a CentOS Stream 9, RHEL 9 build is cut from Fedora, whether it's Fedora 28, which was for CentOS 8, or 34 for Fedora 34, which is going to be, or is upstream of Red Hat Enterprise Linux 9. Those paths to contribute are fairly well established.
Excellent. So do you see, from the Rocky standpoint, the Rocky community, I mean, it's massive already for the age it is. I mean, having 15,000 plus people in that community, it still blows my mind, but enabling them to quickly give back to SenseStream at an enterprise level and not have to go up all the way through, what kind of impact do you think that's going to make on enterprise Linux, and kind of how that's going to shape Rocky?
I think that's a really good question. And in a lot of ways, CentOS Stream, the changes there were shaped by hyperscalers like Facebook that were looking to get their changes integrated faster into Red Hat that they were using, or CentOS that they were using, and didn't want to, or didn't have the time to wait for those changes to be pulled down all the way from Fedora down into RHEL eventually. And so it's exciting that there's a lot of work happening in CentOS Stream, not only by community members, but by developers as well. And I think it's a really awesome opportunity for the Rocky folks to contribute to that if they want to, but also have an area inside Rocky Linux to contribute things that are specific to them, that not that they don't want to bring upstream, but that are more specific, that have to be held inside Rocky. And I think that's something that we'll be seeing more of this year as we deploy a new build system over there.
Excellent.
You touch on hyperscalers for a moment, and I'll jump in really quickly about kind of the HPC side of things. One of the big focuses, one of the big kind of consumers of Rocky Linux at the moment that we're starting to see is supercomputing sites. It's very well established in HPC that one of the kind of standard operating systems that's used across clusters was CentOS 7 for a very long time. There's a lot of clusters out there that were running it for their head nodes, compute nodes. A quick, cursory glance over the top 500 will show you tons and tons of systems on there that are using it. And that, in a high-performance computing environment, typically you have hundreds of users on at any one given time trying to, share the resources that are available across the cluster. So with that, job schedulers and databases and all that, it's already a sensitive enough environment, and it's difficult enough to get those environments kind of ready for a maintenance period. That having to move from OS to OS in your cluster is not desirable. That takes a lot of time, that takes a lot of effort, that takes lots of planning to be able to do something that major with all of your high performance computing architecture. And so for one, the move from Cent 7 to Cent 8 was already something that I don't think a lot of sites were really starting to think about, because Cent 7 is pretty well established as a reliable and solid HPC operating system. And with the end of life for that being still a ways out, there was really a lot of reason to switch over there. But what I think is great about Rocky Linux is that now that Cent 8, that clear upgrade path for some of these high-performance computing sites is no longer so clear, with CentOS 8 being end-of-life. I think that one of the great things about Rocky is that it provides that necessary alternative for a lot of these high-performance computing sites that don't want to add the complexity of having to manage Red Hat licenses and across potentially dozens, hundreds, thousands of nodes at once. What Rocky provides is not only a free alternative to that, but a way to avoid having to, like I said, go into all that kind of specific licensure management stuff like that. Essentially management that places haven't had to do before, but that would add a lot of complexity to their operations to have to scale out and manage. And so Rocky really provides a great upgrade path for anyone in high performance computing that's looking to move off of CentOS or even Red Hat if you're looking for something that doesn't have that type of management. I know that managing software licenses for all these specific pieces of high performance computing software is already difficult enough. So yeah, one of the big draws of Rocky, I think, to the high performance computing community is that it provides that community alternative that was a lot of places rely on and have relied on for a very long time to run their high performance computing clusters on.
So Forrest, in those types of environments, going through that, I mean, a lot of that stuff's been around for a while. They get very solid, very stable performance, so they just don't touch them. They leave them alone for long periods of time. That's been around, kind of like some of the smaller enterprises or even enterprise where you have legacy tech debt and things that you just don't know how to rebuild anymore. Are you seeing people start to adopt more configuration management, automated deployment type infrastructure or type processes into that environment, or is it still trying to catch up?
Honestly, it kind of depends upon the site that you're at. We talk about small to medium businesses and kind of how they, are working with configuration management and automation. The first thing I think of is, small to medium high performance computing sites, because it's a very similar thing. There are a lot of places out there that are basically just running a couple of clusters. There's the universities, for example, that are kind of running, a couple of smaller clusters that are meant to serve out some resources to their users at their institution. But that don't have a lot of people or, a lot of cases, a lot of time to be able to, look into that kind of configuration and automation type of stuff. So I think that especially as we kind of see these things move into the cloud, we kind of see a greater proliferation of these type of tools across HPC. High performance computing has traditionally not been a field that the absolute latest technology gets into very quickly. A good example of that is containers. which for a long time until Singularity was kind of built, now Apptainer, of course, but originally Singularity. For example, there wasn't really a good way to deploy containers in a high-performance computing environment. That suffered from a number of security pitfalls and kind of other issues with that specific multi-user environment. And so we see kind of a pattern in high-performance computing, as I said, of these technologies slowly making their way into that. And I think that especially with kind of the move of a lot of sites to wanting to more manage cloud resources as opposed to actual very large on-prem racks of HPC servers, I think we're seeing kind of a wider proliferation of those tools coming about as a lot of these HPC people start to realize that, these provisioning tools and being able to scale up, being able to scale up automatically and load balance and things like that become, needs as our, science advance and our simulations become more intense, and we want to, run, for example, just an example of a use case, we want to run more GPUs on our machine learning models. As we see the scales get greater and greater on things, I think that we'll start to see more and more people move to the cloud and kind of start to look into those automation and kind of configuration management tools. Because just the necessity, just where the technology and the science is going will necessitate larger clusters and more power to be able to, be easily put to the task at once, even just for smaller sites, just like I said, due to the nature of how things are advancing. And so, I think that we'll definitely see more of that type of usage as it kind of starts to pick up here over the next couple of years. But there are definitely some places out there that don't have that infrastructure and don't have the time to set up that infrastructure yet. But like I said, as there's more demand for the cloud, that'll kind of hopefully even help to ease some of those tasks that go along with management of high-performance computing clusters on-prem. And you'll free up time to explore those technologies and maybe see greater proliferation from kind of across the HPC community of that stuff into HPC.
I think something that, just to tack on there, like, coming from the enterprise space, you can wait, especially with the pandemic now, like years to get servers and switches. And so there's definitely a cost benefit analysis that you can do there for how much you're spending, not only for your power and space and internet usage and everything else, but how much time you're spending on human resources, making sure that everything's configured and patching all of those systems and the switches and everything else. And one thing the cloud does, especially for the smaller side of things that maybe haven't reached that critical mass to have a team of people that are responsible for just the networking for those servers or whatever. One of the things that the cloud offers is you don't need those people, and that's not to say that those people aren't necessary, because they are. They're just in a lot of ways needed in these cloud environments. And I can go back and forth and probably spend a whole hour talking about the centralization of everything to these clouds, and you see outages too. So I think there's a lot of things you have to consider when you're moving to the cloud. It's not necessarily as simple as I got 10 servers and that's going to be this many cores on some EC2 instances. You have to kind of think about your disaster recovery, and especially moving to the cloud, I think, is a really great time to think about that configuration management and to take the time. As you said, there's still a few years left on the CentOS 7 EOL. Take that time to plan your migration. Think about how you can do these things in an ephemeral manner where it doesn't really matter too much if your server just falls off the roof or if US East 1 goes down.
Mm-hmm. Yeah, I think that's something that we don't. I mean, from a consulting background, we ran across people who didn't take any of that into account. They would think just moving a server to the cloud made them where they would never have an outage or a problem. And they would also just leave them on all the time. And I think that's where people run into the cost problem, is not actually identifying, does this resource need to be on 24 hours a day or does it not need to be? And being able to turn things off and doing it in an automated way, you can save a lot of money if you identify those different types of use cases and workflows that you can do that. I think it's important. And I think it's interesting for us that we start looking at HPC in a hybrid model where you're having not just that on-prem HPC environment but being able to scale into cloud. It's new and exciting. It's different. Mm-hmm.
And as you both touched on there, there are definitely a lot of complexities to setting up these things in the cloud. It's definitely, it's already a complex enough task to set up, an on-prem supercomputer. If you're, standing up, high-speed networks like InfiniBand, you're standing up, management networks. There's all kinds of different considerations that you have to take into when you're building something on-prem. And to be frank, it's that same way in the cloud. I know that some of the major cloud providers have different types of, different kind of HPC stacks that you can deploy on them. I can't speak to the maturity of them. I haven't deployed some of AWS's different kind of massive GPU deployments. But there's definitely a lot of complexities that are involved there that are very similar to what goes on-prem. It's setting up resource managers, databases for those resource managers, setting up the MPI stacks that allow these instances on these clouds to be able to talk to each other, figuring out what even instances can support the high performance networking that's necessary to make a compute cluster work. So there's a lot of considerations that go into this. A lot of it translates pretty simply, like I said. You're already probably used to working with InfiniBand networks in your on-prem HPC. There are definitely ways to get those in the cloud providers, but it's definitely not as simple as just spinning up some large compute node like instances and starting to run stuff on them. There's definitely a lot of complexity and a lot of as we've talked about, configuration there that can be automated and should be automated for the ease of people's time and getting things up and running quickly. And some of that, obviously kind of comes from the ability to scale and stuff like that. There are specific, configurations that are useful in a cloud environment that even beyond just a, simple cloud cluster would be useful. Like I said, a good example is auto scaling. A user submits a job to your cluster that's far bigger than you have capacity for. Being able to automatically scale up the nodes there, that you're running in your cloud cluster is obviously something that you can't easily do on-prem. And so there's a lot of complexities there that have to be kind of taken care of as well in similar ways to how they would be on-prem. And the hybrid cloud model is very interesting because we kind of see that coming up a lot. As institutions and different HPC sites have these very large clusters that they've expended huge amounts of time and money into over the years. That's definitely a big concern, is being able to still take advantage of those resources and not just have to essentially waste money in the end by mothballing them. So there's definitely a big need for kind of hybrid cloud solutions in high performance computing, especially those that could do something, be able to serve things out to clusters in the cloud, clusters on-prem at once. There's a need for that kind of thing at the moment. So as I said, as things kind of move to the cloud in general.
What kind of things is the HPC world looking at to solve some of those inherent data gravity problems that come from a hybrid cloud model? Where you have maybe petabytes even of data that you want to run on workload in AWS and as well as on-prem or maybe GCP or something. Do we have good solutions?
I'm not sure quite yet. And that, this is kind of the era that we're starting to get into of big data. I mean, we have, it's really only been within the last 5 to 10 years that we've seen, mass proliferation of, for example, one of the biggest consumers of big data, machine learning. So I think that in general, there's a lot of kind of solutions that are out there for that type of data warehousing and that large scale storage of data. But as far as moving them between the cloud and kind of these on-prem stacks where there may be high performance computing clusters that have large petabytes worth of storage attached to them that obviously can't be easily moved up into the cloud. I am not 100% sure exactly what solutions are being explored there, but I imagine that we're seeing a similar proliferation with how we're seeing all the specialized hardware that's coming out to process this big data that we have, different accelerators and things like that. So I think that if it hasn't already started, we'll see a very similar proliferation in the big data sphere, kind of like, for example, as I mentioned, what we're seeing with all these different specialized hardware accelerators and things like that coming out, because perhaps before we weren't as concerned with the data because we were running small models, we were running things that weren't difficult to move around. But definitely now that things are recently starting to get into petabytes and petabytes of data that one model might need, like I said, to use the machine learning model example, there'll definitely need to be tools there that allow for that kind of easy movement of data between cloud and on-prem.
There's definitely cost to be concerned about there too.
Mm-hmm.
Absolutely.
Mm-hmm.
That's where you start wondering if sorry, Forrest, go ahead.
I was just gonna say, because obviously that type of ingress and egress is pretty difficult. Even if you're using some of the kind of archival storage solutions. I mean, those have pretty high egress costs to them. So I think a lot of it is just kind of figuring out at your organization what your budget model is and what fits that. If you want to, if you're going to be using the cloud extensively, do you want to spend the money that it's going to take to move all of that, those petabytes of data and store them in, S3 or something like that, so you can ingress them quickly into your AWS cluster? I think in the end, it kind of comes down to what solution works best with your organization and what works best with the budget, because there's multiple different ways of going about it. Even like per cloud, there's multiple different storage solutions. So I think it comes down to what you think your overall cloud utilization is going to be. How much are you going to have to deal with that data gravity over time? I think that could kind of guide a little bit of the decisions on where you move that data off of these on-prem systems and into the cloud.
I started thinking about the way that whenever people started using cloud and being able to actually direct connect, get a network connection from your local environment into the cloud so that you had that transparency. I wonder if it's going to become that way with data as well, where in some places you'll just physically have your personal infrastructure sitting right next to the cloud infrastructure and some sort of connection between the two. For speed and scale, it seems like that would be the next progression if it hasn't already happened. Might probably has, but it seems like that would be kind of where we're headed.
There's a lot of people in Ashburn.
Yes, there are. So I think great conversation, guys. I think the last thing that we wanted to talk about was PK exec. I know that's something that's kind of been hot on the internet lately, and everybody's talking about PK exec and the vulnerabilities. So I think now's a good time, Neil, if you'd like to chime in on that.
Yeah, absolutely. Yeah, that was a kind of weird bug that's been sitting around there in the open source world for
12 years.
13 years? 12, 13 years, yeah. Interesting, I think, to say the least about that, and to look at the changes that have been made and discussions that have been having in the open source community in the Linux kernel. For example, there's a patch upstreamed to, I don't know if it's been accepted yet, but to actually fix this at the execve level, where it will just error out if you try to supply these things. And there's some considerations there too. I think that we're in for a bit of a rough couple of months here as people find more SUID libraries that are going to be affected. And for those people that don't know, there was a vulnerability last week in Polkit, which provides a layer between the operating system and how things are supposed to be executed, basically. So there's this function called pkexec, which was able to be exploited to send it some bad environment information. And essentially, any user could compile a script, a C program, and just get root. And so it kind of points towards the importance of having a strong security model, and also it lends itself really towards things like rootless containers, where you can't actually escape those even if you try really hard. And so I think that is something that Greg picked up on, and that day he was asking me, hey, this script isn't working, and why isn't it working on Rocky? The exploit script that was all over wasn't working. It turns out it was just kind of a GCC flag that needed to be set on it, but he went through and ran that on, I think he has a YouTube video on it, on Apptainer, formerly Singularity, and showing that the model there with the CIF files and how the container runtime is orchestrated, it doesn't allow people to escape from that shell, even with that exploit. And so that was pretty neat to see, I thought.
Especially with kind of the vast proliferation of containers at the same time across everything. A lot of these container runtimes are not exactly built with the similar security model that's unique to Apptainer. And so we were pretty pleased to see, that being able to take care of that and actually stop that exploit because of the security features that Apptainer just has built inherently into it, in its runtime and in how containers are executed and how users are able to interact with those.
Yeah, I think that's a great point. And there are more secure distributions out there. Like Alpine Linux, for example, wasn't affected by this at all because they don't use glibc. They use Musel as their C compiler or interpreter. So there's definitely other things out there that are possible, and Alpine has container images that are great. I use them myself. But having a container runtime that is really thoughtful and secure and is something that I think is really powerful and important.
Absolutely.
And that's not
Guys,
to say that Kubernetes and everything else aren't getting there and working on it, but I don't know.
It should be noted that Apptainer was specifically built for those type of secure use cases. This is a really common type of thing that you would see in high-performance computing, the need to have that level of isolation between users inside of the container, or the need to have, my apologies, that kind of privilege isolation. There are other ways that Apptainer works to more kind of integrate than other runtimes the capabilities of the host into the container, and there are high-performance computing reasons for that. But yes, it was very neat to see Apptainer able to just stop that wholesale.
It's excellent. Well, guys, we've reached the end of our time. Be respectful of everybody's time, and I appreciate Neil, Boris, for coming on.
Thanks for having me.
Always fun to talk to you guys. I appreciate your time, and looking forward to part 3 of our conversations here in the next couple of weeks. So thank you again. Go like, subscribe. Follow along with us on this. We appreciate it.
Smash that like button.
Yes. Thank you, Zane, and thank you for having us. Thanks, everyone, for watching.
Thanks, guys.
Thanks, everyone.